Okay. Now the class is recorded. Again, I will show important points in important topics in the Canvas that I would like to be attention to it. The first is me class. Okay. I use YouTube to publish the video that we recorded in the class. Okay. I have, give me a second. I have your channel, playlist. We have a playlist here, this one. Okay, I'll stop. Okay, this playlist has all the content of our course. Okay, I share this playlist in the Slack. Okay, but independent that you see this playlist, you have all the class I will publish here. Okay, the session 1 I will publish late. The first class that will introduce the course. The session 2 is today. I will publish after our class. Okay, I will publish the both videos today. Okay, don't worry about it. So another important feature is in the models. Here is the place where you're looking for the content of our course. For example, the model 0. You have the what is the we talked in the first class, one video, and that explain what is Internet of Things. The PDF of the material that you use in the class, and I put here the I set here the video link. Okay, you have the video link here inside the top inside the model, and you have the video in me class. Okay, you have in two places the videos. Okay. Any question about the videos of the record video of the class? Okay, you have again in two places, in the inside the models and in the me class. You choose the best place to find. Okay. Another thing, I changed the view to student because it's little easy. No. Okay. Here in the section 3, you can see the what you discuss in the model 5. Okay, you can see the class yet. Okay, because this class will happen late, but you can start to see the model 6. Okay, in particular the today class. In the today class, you have the introduction of IoT. Here you can see the what you will talk about and the PDF of the class. Maybe on Monday you can see the material. Maybe no. On during this weekend, maybe on Saturday, you can see the material of the class of the next Friday class here. Okay. You go here, you can see the topics, and you can download the PDF. You can see the video if you have any videos about this class. Okay. Use the models to looking for information about the topic that we discussed. And we have one activity that you don't worry about this activity, you talk about it today at the end of this class. One first activity that you need to do, okay? But we discuss this activity at the end of the class, okay? But what I try to explain is everything about the course here, you have here in the Canvas, okay? You need to, every day, to constantly you check the models, and to check if you want to see the class, you check in the Me class. Okay. Another important tool is the Slack. I already set the Slack, the group of the students, GSL 531. We have 531 students here. There are some students that is not here because I didn't find the names in the canvas. I would like to make a double check with you. Give me a second. I would like to check some students that I didn't find in the Slack. I would like to check with the students here and to see if you already connect in the Slack. The first is Adrian Aguilar. Did you already connect in the Slack or not?
No.
Did you have the link?
I'll do it now.
Okay, please. The next one is Andrew Steven. Are you here? No. Carlos Damian.
I'll join now.
Okay, please connect to Diego Andres. Okay, Mama. Diego is not here too. Juliette Trejo. It's all. Okay. If one of these students, you know, when it is doing this course, please alert them to connect this Slack. Okay. So just to check here, Adrian. No, Adrian Aguilar. Please, after you connect to, can include here. We use Slack, not only I, but the other professors use Slack to share information, okay? For example, I saw here Luis Yepes publish a game, maybe use this game to teach in the class. I sent the link today. I don't know if everybody has the link to connect. I publish here, I publish the video one. We use this group a lot to discuss, for example, to send some updates or to share additional information. Okay. For example, it's very common. For example, you have a discussion with one group, but you think, oh, this question is important to the whole group. Okay. And you use Slack to share this question to everybody really knows about what is discussed in the specific group. Okay. Any question, guys?
No.
Okay.
No, teacher.
Thank you. So I will stop the record. Okay, to don't. I just want to stop to record. I share my screen. So Can you see my screen?
Yes.
Okay, Esther, thank you. So now we start the course, no? And today, the idea is, at the end today, you have the idea about what is the course, okay? What is the main topic of the course? You have a lot of different other things, database, digital sign, but the reto or the final of the course, what is the capabilities, what is the skills that you need to have at the end of the course? And to be possible, the next two class is about IoT architecture to enable to build a big picture of what is IoT, how to apply IoT, what IoT is important, what is the real scenario that you can apply, how IoT changed the way to work in the internet. Okay, it's the main idea of the class today and the next class in the next week. Okay, so before we start the course, I would like to talk about things that you need to know. Our course is a competence-based learning. Okay, what it means? You all the times you are involved in a problem and you need to think and to use the skills that you're learning in the theory part. You need to apply these skills in the real scenarios. Okay, again, in the beginning you don't know a lot of things. You apply very abstract concept. Okay, but at the end of the course you learn a lot of things and you can apply and implement the solution, a real solution to a problem. Okay, and our course is, give me a second. Okay, our course it's directly correlated with the citizen and sustainability. Okay, last year we worked in a project is very accomplished with sustainability because you at the end in the reto you develop a smart waste system. Okay, today it's a little different approach, but the solution is involve sustainability, and we'll show during the course what to apply sustainability in the reto. About ethics and citizenship, the case that we work in the reto, we discuss the reto in the next week, okay? But the case that we work in the reto is directly about the citizenship, okay? These two topics we'll discuss in the next week, okay? Innovative and digital transformation. IoT is not real new, okay? The new is you have capability to use to end device, send data and receive command. It's the new. But for example, you can use your smartphone as an IoT device, or you use your smartphone as a device that has intelligence to use different IoT device to produce decisions. Okay, you see during this course, in particular today in the next class, a lot of time when you think about the IoT course, you think about the programming of Arduino or programming of Raspberry. Okay, you see how to program in Raspberry. Luis Yepes you showing, but things a little more high, a little more close to the cloud. Okay, the amazing things with IoT is to produce intelligent systems. Okay, a very nice intelligent system. Because now you can connect many devices. For example, you can connect all devices in your home and produce, for example, intelligent system, like for example, to reduce the consume of electricity in your home, or consume of water in your home, or to keep the home nicer, comfortable to use. Okay, you see a lot of different applications, and you can have a new innovative ideas. You see that IoT is it's completely innovative. You can do anything that you think. Okay, what you need to do. Okay, the chat. What is the chat? Yes, I believe yes. Just to make a double check. Give me a second. Give me a second. I make a double check if it is in the canvas. Yes, as in here, okay? In the model, session 3, model 6.1, okay? And introduce our IoT. You have the PDF or PPT here, okay? Okay, second to return. Okay, guys. An important thing, there are a lot of cases that I prepared a material before the class, okay? Sometimes it's a video that introduces the topic. Sometimes it's a reading, a short reading to introduce the topic. Sometimes an exercise, okay? But it's important to check before the class the materials, if you have some materials in the canvas, okay? Maybe, for example, for the next week is the good idea to check on Monday. Check if you have some material there, and during the class you discuss about this material, or you realize an exercise about this material, okay? And after the class, a lot of times after the class, you have an exercise to perform, okay? And I like the flipped classroom. I use a lot of time in the course I use this approach. But again, follow the canvas, but I teach, okay? I'm not a coach, I'm a teacher, okay? But most of the time I use some videos. I like to use videos to explain the big picture, okay? And I use a lot of videos in our course, and I publish much of this video in the canvas before the class, okay? So, I believe I share my screen. I don't know if I share the audio. Give me a second. Yes, I share the audio. So I have this first video. I believe this video is in the canvas. This video show some examples of IoT application. Okay, it's about one company. However, it's a nice video to understand what the IoT talk about, okay? Please pay attention, and we'll discuss later, okay?
The global population continues to grow and age as people live longer. This calls for innovative ideas to manage the planet's resources and to deliver services to everyone. As the population shifts towards cities, the challenges to manage traffic, pollution, and energy increase. At the same time, people have greater access to information, products, and services that are increasingly global, and they expect these to be tailored to their individual needs. At ST, we believe that technology can help meet these needs and contribute to our vision of an augmented life for everyone. Let's see how. ST continues to develop solutions to make the world smarter and more connected. Our sensors provide information about the world around us. Our microcontrollers process, protect, analyze, and act on this information. Our connectivity products provide the link to the network, and our energy management solutions ensure smart systems operate reliably and efficiently. In cities, these systems can be embedded everywhere, in buildings, attached to street lamps, or even buried under roads. Together, these devices enable the smart grid, allowing more efficient use of energy. In factories, they combine with ST's smart power components to create extremely reliable and efficient automation solutions. ST is also making cars smarter. We are improving safety on the road by helping cars detect obstacles and assist braking, or adapt their speed to the flow of traffic. ST technologies also help protect the environment by reducing fuel consumption and CO2 emissions. And ST infotainment, navigation, and in-car controls increase the enjoyment and comfort of the overall driving and traveling experience. In the home, our technologies allow management of lights, heating, or any home appliance that embeds a smart system, and when connected to the cloud, enable us to remotely monitor and control our home. ST Solutions deliver music, movies, and information to all the connected devices in the format they need, when they need it. We offer the latest innovations in home entertainment for an immersive viewing experience and stunning realism for live-action sports and gaming. Smart systems collect information to tailor applications and services to specific individual needs, while offering a more natural interface for a richer user experience. And ST's long experience in data security and secure communications ensures that your personal information will be safe. Real-time monitoring of activity and personal data can give advice on diet and exercise, provide early warning signals for critical illness, or improve drug delivery. This same technology can also keep us healthy by helping to deliver medical services to everyone at an affordable cost. The proliferation of smart systems will connect many new devices to the Internet of Things. This will increase the amount of data to be transported, stored, and processed, creating the need for a more powerful infrastructure. And ST has solutions to meet the needs of this growing cloud with innovative, low-power, high-performance technologies. Together with our customers, partners, and employees, ST is using its technology, know-how, manufacturing capabilities, and talent to meet the challenges and opportunities of the evolving world. Because everywhere microelectronics makes a positive contribution to people's lives, ST is and will be there.
Okay, the end of this video is marketing, no? But again, what is the IoT? What is the Internet of Things? The Internet of Things describes a network of the physical objects, okay? Anything, okay? For example, it's the net. What is the things that you can have in this network? Can be your smartphone, can be your smartwatch, can be the air conditioner, the lamps, anything, refrigerators, your car, anything that you can think. Okay, the IoT is the network of the physical objects that are embedded with sensors, software, and other technology to connect and to exchange data with other devices and systems of the internet. For example, today, I use my smartwatch. I don't have my smartwatch today, but I have a smartwatch and I use every day. Okay. Why I use the smartwatch? I use the smartwatch to control my agenda. I use my smartwatch to control my my health condition. For example, the blood pressure. I measure my blood pressure every day. Use my smartwatch. When I go to the gym, I use the smartwatch to measure my health condition during the exercise, to calculate how many energy I consume. My oh sorry, I use my smartwatch to do everything. For example, my smartwatch connect with my agenda to, for example, to send alerts. For example, oh, you have a meeting now, you have a class now. My smartwatch connect with my cafeteria. For example, my cafeteria is a IoT device. If I miss it, for example, unlock the cafeteria, I receive an alert in my smartwatch. Everything, for example, in my office, I have a lot of device that is smart and connect with the others and send information to the cloud, calculate and make some statistics. And for example, my smartwatch send a lot of data about my performance. And every day I receive a report from the cloud, for example, about what I did wrong, what I need to improve. And amazing things about my smartwatch is I discovered 2 weeks ago. I run for 1 hour, and my smartwatch collects a lot of information, send the information to the cloud, and the cloud sent a report to me. And during this report, I receive, for example, during all the times, second by second, what happens during my the time that I make an exercise, and send some feedback to improve my performance. It's amazing. It's what is about IoT. Okay. The most important things, or the base component in the IoT, is the thing. A thing can be a person with a heart monitor implant. Okay, there are nice move. I cannot remember the name, and there is a nice move. It's like I cannot remember the name of the move. That a guy, the president of the United States, has a monitor implant in your heart to control the medicine that the president receives in the monitor, and to receive in the heart. Okay. And so the hackers invade the system and change and compromise the behavior of the system. But it's a system installing in the president. Okay. You have some biochip implanted in the farm animals. For example, the control of the very, for example, the penguin in the world. When the guy found one penguin, implant a chip in the penguin, and you can control where this penguin is. For example, if suffer something, it's a nice application. Cars has a lot of built sensors that send data one to other. For example, aircraft is the same, drones is the same. Okay. Anything can be a thing. To be a thing, you need to have an address and you need to have connection to the internet. When you think about the IoT ecosystem, you have sensors, for example, air conditioners, lamps, surveillance cameras, air refrigerators. For example, all of these devices is installed in a home, okay? And you have multiple sensors. For example, you can collect the temperature in the rooms, okay? And you can see if the lamp is off or on. You can capture the information from the cameras, and you can see, for example, the stock of stock of food that you have in the refrigerator, okay? You have multiple sensors that collect data. But it's not useful if this device don't have connective, okay? This sensor here, the air conditioner, they need to have connective to the other device or to the internet. It's the same of the lamp, it's the same of the surveillance systems, it's the same from the refrigerator. All of this information is sent to a place to process. For example, the temperature of my home is 25 Celsius degrees. Okay, it's nice. But what it means, for example, is 35 Celsius degrees. What it means, okay? You need to process this data. You need to transform this data in information, okay? You need to transfer this raw data in information. For example, 35 degrees. Oh, it's hot. Or 18 Celsius degrees. It's cold, okay? You need to transfer the raw data and information, okay? You need to make data useful through the data process. And you need to have a user interface or user application to show this, to inform this information, to show this information in a useful GUI or the useful user interface to enable that the user can consume this information and send some feedback. For example, you see in your app that the temperature in the home, in your home is, for example, 35 Celsius degrees. And you think, oh, it's hot. And you can press the button and turn on the air conditioner, and you can set, for example, the air conditioner to change the temperature to 35 to, for example, 21, okay, Celsius degrees, okay? You use this user interface to take this decision, to interact with the things. Did you understand? Any questions?
No question.
Okay, thank you. You can use the chat too, okay, guys, to make questions. But again, in the beginning of the internet, you have only a small device. For example, in the beginning of the internet, you don't have cell phones. You have a computer. Most of the time, you have a shared computer. For example, I started to work in the internet in 1994, yes. In Brazil, okay, it's not the internet in Brazil, but I started to use the internet in 1994 or 1995 is the time that I bought my first computer. And my computer, I have one computer in my home, and my computer I use and my wife used too, okay? In my office, I have a computer in my desk, and it's not in my desk, it's a desk in my office, and the 5 guys that work in my office use this computer to send mails or to get some information from the internet, okay? When the smartphone like you have today appears, it's changed because appears the laptop, that the laptop is my laptop. For example, in my office now, I have my laptop, my daughter has your laptop, the 2 employees that I have has your own laptop, okay? It's a little different because now I need to have 4 addresses. In the beginning, I have 1 computer. I need to have 1 address. Now I have 4 addresses because I have 4 laptops. When appears the smartphone, now I have my laptop and my smartphone. So one person, need to have 2 addresses to use I need to have 2 addresses. If you think, for example, now you have a smartwatch, you have a computer, you have sometimes a laptop, you have your smartwatch, smartphone, your refrigerator, the number of addresses that is required is much more. The number of the size of the bandwidth, the quantity of the bandwidth that's required is much more. If you see this graph here, give me a second to if you see this graph here, it's the beginning of internet. You need to have millions of addresses or millions of devices. When appears the smartphone and laptops, it's become a billions. Now, when every device need to have an address, for example, my air conditioner has an address, my cafeteria has an address, my smartphone has an address, my smartwatch has an address, my Alexa that I have here has an address. Everything needs to have an address. Is the internet of things. The numbers is much bigger, and the bandwidth is much bigger. For example, in the beginning of the internet, you have, for example, in this time here, a good connection is at, I try to change to, yes, here. For example, here, the connection is around 36 kbps. Oh, I changed the color, give me a second. No, yes, 36. If you have here in the 90 years, 36 kbps, you have a good connection. If you have 5, 6, you are rich guy, okay? What is 36 kbps today? Nothing, no? You can do nothing. Okay, when you start to have the beginning of the cell phone goods network, you have around kbps or 256 kbps. Oops, sorry. It's around the years 2000, 2009. It's the speed of the internet, okay? And now you start to have, I believe in Mexico too, the 5G. Oops, 5G, okay? You have a megabps, okay? You can transport data in around the gigabit per second, okay? The network now can support it. In the past, is completely impossible, okay? It's the challenge that you have now when you think about Internet of Things. So, what is the IoT questions? The IoT question is, in the beginning, you have humans interacting with humans. Now, you have things interact with things, okay? Interact, contribute, and collaborate, okay? For example, I can set in my smartphone that the good temperature that I want to, when I arrive in my house, 7 p.m., the temperature of my home is around 22, 23 Celsius degrees. Okay, I set it in my cell phone. I don't need to do nothing because my cell phone, my smartphone, talk with the air conditioner and say, air conditioning, is the time to turn on. Okay, not 7 p.m., but 6 p.m. or 6:30. Turn on 6:30 to be on 7 p.m. The temperature is around the 22 or 23 Celsius degree. Okay, it's the things that change in the IoT paradigm. In the IoT paradigm, the things talk with things, the things interact with things, the things send data, share data with things. You don't need to have human in the middle. Any question, guys?
No, teacher.
No questions. Wake up.
Okay. My English is okay, or do you need to speak slowly, or you need to improve the how to pronounce the words? What do you think?
Everything's okay.
Okay, perfect, Ernesto. Thank you. So, the benefits to use IoT. First, efficient resource utilization. If I have sensors installed, a lot of sensors installed in my home, okay? If these sensors send data one to other and can interact with other and collect a lot of data, and I use artificial intelligence algorithms or artificial intelligence systems that can analyze this data and see, oh, the best combination of this sensor, it is the best combination of this sensor to produce, for example, to reduce the bill or to produce the best quality of life, okay? The first benefit is efficient resource utilization, because when you use a man in the middle, no artificial intelligence can replace the man, but the artificial intelligence in the middle, when you take off the man and to give the power to artificial intelligence can work better than to the man, because the man, for example, things that you need to check the temperature of the home and see, oh, air conditioner, turn on the air conditioner, turn off the air conditioner, okay? Turn on the air conditioner, oh, it's cold, turn off. Oh, it's hot, turn on, okay? If the air conditioner talk with the, for example, the home system and interact information, the home system can calculate exactly what is the best time to turn on, what's the best time to turn off, okay? It's the thing. Minimize the human effort. Again, machine is good to do boring things. Human is not good to boring things. One example, I'm a pilot, you know, and the very difficult thing to a pilot is to concentrate and to keep the aircraft in one level. For example, you need to fly in, I don't know, 2,000 feet from the ground, okay? To fly exactly 2,000 feet all the time is very difficult, okay? You lost small altitude, you increase small altitude, but aircraft, when you use the autopilot in the aircraft, the autopilot is very nice to do it, okay? Autopilot can think a little ahead and compensate all the aerodynamic conditions and to keep the aircraft fly exactly in the altitude that you want, okay? Why? Because it's boring to control it. It's nice, okay? In the beginning, it's nice, but fly, for example, 3 hours. It's very boring to do it, okay? Send this task to the computer and just only supervise the computer, okay? Next one, development of artificial intelligence through IoT. I already told you about it. You collect a lot of information. You can use artificial intelligence to aggregate different information and to produce insights or produce intelligence through this data. and save time. Again, human is not good to make calculation, spend a lot of time. Machine can calculate very fast and in the small time. Okay, one example of IoT application. Think this situation. One guy suffered one accident, for example, crash, two-car crash, and one guy is bad, and you need to call an ambulance, okay? And the doctor in the ambulance puts a lot of sensors in the patient, okay? And these sensors can calculate the health condition of the guy and send this data to the hospital, okay? You can see the blood pressure, you can see the temperature, you can see a lot of information about the patient that suffered the accident. The doctor in the ambulance can send some data, okay, can send some prognosis to the condition of the victim, and you send this data to the using the cloud, you send this data to the hospital. In the hospital, you can use artificial intelligence, or you can use doctors and to prescription ahead what this guy needs, okay? And you send this prescription to the farm, to the pharmacy, and the pharmacy can separate the medicine. And depending on the condition of the victim, you can make resource allocation. For example, oh, this guy lost a lot of blood. Oh, you need to have blood in the hospital. You allocate blood in the hospital. So another thing, the guy needs to suffer a surgery, a small procedure. You can separate the research, the required research to this procedure, okay? Before the guy entering the hospital. When the guy entered the hospital, everything's set, okay? Did you understand the case? Any questions?
No, everything's all right.
So, how does IoT works? So you have five layers. The first layer is the perception, okay? Is when you collect the data, things about the air conditioner. The air conditioner needs to have a temperature sensor to collect the temperature of the environment, okay? Is the perception layer, okay? Is the layer that collect data using sensors. There are another type of device in this layer. For example, when you need to receive command, okay? You have a sensor that you have a sensor that measure things in the environment, and you have another device or another component that's actuators that receive command, okay? That receive command from the environment and change the behavior of the device, okay? Both kinds of systems is in a perception. You have the pre-processing. The pre-processing, you can filter or summarize data before sending it to a network. You'll talk better about it in the next class when you start architecture, IoT architecture. But think in this situation. You have a sensor that produces a large amount of data for seconds. For example, each microsecond, the sensor measures something and is able to send this data to the cloud, for example. You flew the cloud and you need a very large amount of bandwidth to support the system. A good idea is to have one device in the middle that close to you, okay? For example, things that you have in these office, one device that receives all the data from the sensors in the office environment. Okay, filter this data and send to the cloud only the change, only the important things. For example, things that your air conditioning, okay, and they receive the data. Oh, the temperature is 20, the temperature is 20, the temperature is 20. You don't need to send all the time, each millisecond that the temperature is 20. You send the first time, and when you change the temperature, for example, oh, the temperature is 21. Okay, you send the update. Okay, it's what means pre-processing. The implementation of the pre-processing is, for example, you have a device close to you have a special device close to your IoT things, okay? And this device receives all the information from the IoT things, but filter and only send the data to the cloud systems when you have some update or some special conditions, okay, that is important to the decision-making system, okay? The next layer is the communication, for example, that provide communication one device to other, okay? For example, use Wi-Fi, use Bluetooth, use the 5G, okay, is the communication layer. You have the middleware, for example, you have the air conditioning, okay? And you have the cafeteria, okay? But the application is off, okay? See, if the application, you have a layer that is more context, it's like a domain context, okay? For example, I have an air conditioner inside the home. It has one context or one domain. I have one air conditioner in office, is another situation, is another application. I have an air conditioner inside no aircraft, is another application. The middleware layer make this translation, creates an abstraction to the device. For example, another example, you have an air conditioner from LG. You have another air conditioner from Panasonic. You have a middleware that translates the difference between IoT device from Panasonic to IoT device from LG. Another example, you have a device that you use a protocol way, okay? You have another device that you use a different protocol. You have a middleware layer that translates the one protocol to other, okay? It's the things that the middleware does. And you have the final application, okay? Again, we study better these ideas in the future. One example about the perception, okay? Again, you have different sensors, okay? Any sensor needs to be small, low cost, and consume low energy. For example, examples of perception layers. You have a magnetometer, location sensor, movement sensor, camera, microphone, light sensor. You study much better it in the next class, okay? Pre-process. Again, mobility. Again, remember that I told you about the middle layer. You can have a smart gateway that provide connectivity to, it's close to the smart device. And this guy interact with the smart device with the cloud, okay? In this device, you have a real-time analysis, okay? For example, in the cloud, you don't analyze in real time because it's far, okay? For example, if you have an application that you need to take decision in real time, like for example, in the manufacturing, you need to have this device, okay? And this device provides real-time analysis and can make decision in real time. Again, about the filtering, You can select, for example, only to send to the cloud the update, but you need to have a local storage because you send the data, the update data, you send only the update information, update data, but you need to store locally because this device most of the time has some analytic or intelligence capability and the some, for example, machine learning capability. And you need to have the raw data to work with machine learning. Okay, it's the reason that you need to have local storage. Any question, guys?
No. No, teacher.
And again, okay, the communication layer. First, you need to have address and notification. The communication layer is the layer that you have the network protocols. For example, my communication layer is provided by Wi-Fi. Wi-Fi produces address, and Wi-Fi has a way to identify the device. Okay. The communication layer handles, for example, address. Another thing is the communication layer needs to have low power communication. Remember, then the thing is not like a computer, is not like a smartphone. One example, a very simple example. Your smartphone, okay, Ernesto, go ahead.
Yeah, I only have one question right here. So,
Okay.
in which state do the encoder or decoder of the addresses could be located? So, in communications or preprocessing, or in which state?
I'm not sure if you understood your question, but I try to answer you and you say me if I answer or not your question. When you talk about the communication layer, we'll talk about the network layer. For example, it's a little different because the network course is after this course, okay? I try to explain, but not go a little deep about the address scan, okay? But again, you have one device, okay? And you need to talk with another device, okay? Another basic example. You have two nodes. I try to explain here. Give me a second. Where is it? Okay, can you see my whiteboard?
Yeah, we can.
Okay. Think you have two nodes, okay? Two guys that want to talk. Guy one and guy two. The communication layer, the first thing is you need to identify this guy in the network. For example, in our case, your name is Ernesto, my name is Alexandre, okay? Okay, my address, your address is Ernesto, my address is Alexandre. However, you can have two Alexandres. Alexandre is not a good name. It's the idea, in our case, you use the ID, for example, I believe RFC ID is a number that only one guy has this number. You can have two guys that has the same number. Am I correct? So the first things that you need to handle is define a scheme that you have one address that nobody is a unique address. Okay, it's the first thing. The second thing is you need to have enough address to support all devices. It's the problem of, for example, in the internet, you use IPv4, okay? For example, your computer, you have an IP, okay? When you connect in Wi-Fi in the tag, receive an IP from a tag, okay? When you connect your home network, you receive a different IP, okay? But inside the IP tag, inside the tag network, Your address is unique. You don't have another device that has the same address, okay? But again, the IPv4 has 32-bit size. What means? It means that you can have 2 power 32, oh sorry, 2 power 32 bits to define an address, okay? Consider it's not true because you have a network address and other special address in IP. But think about it. You can have, I make this calculation. Give me a second. 2 power 32. Oh, sorry. Give me a second. I need to change my scientific. Yes. No. Oh my gosh, give me a second. 2 power 8. 2 power 32. Okay. It means that you can have this number of device using IPv4. Again, it's not true because in IPv4 you have special address, okay, that you cannot use to assign to device. But it's the number of device, okay, that you can have in using IPv4. What do you think? It's good or it's a good size? It's a good number of the address that you can have, or it's small, or you need more? What do you think, Ernesto?
Yeah, I think that it would be enough for the devices we have.
No, because the IoT is not enough, okay? Because again, it's not exactly the real number because you're learning in the network course that you have class of address and you have net address. It's not exactly this number, but this number is not enough thinking that all device in the world, your smartwatch, the cafeteria, and the new device that appears in the future need to have an address. This number is not enough. It's the reason. A second. Oh my God. IPv6. Okay, IPv6 use 128 bits. If you calculate this number, 2 power 182. Oh my gosh. 2 power 128. It's the number of address. Again, you have a special address that you cannot use IPv6, okay, because it's special address, but it's the total of number. In this case, it's enough, okay? The internet can increase large. You accommodate, for example, I don't know 10 years ago, but for the future, the 10 years ahead, it's enough to the internet, okay? When you think about the address, first, it's the first problem that you need to manipulate, okay? You need to assign address to identify each device in the internet. For example, you have some device that has more than one network interface. For example, in my laptop, I have 2 Wi-Fi and I have a cabling device. Sometimes I use the both in the same time. Okay, in this case, I need to have 2 hours. Did I answer your question, Nestor? Or not?
Oh, yeah, thank you.
Okay, perfect. Again, I need to stop it. And he share. Again, this course, you don't go so deep in others because you're learning it in the network course. The network course will happen in the next semester. Okay, next year, in the beginning of the next year, you study network course and you study about IP in detail. You study what is IP, how IP, how to design, for example, about the IPv4. How to define others in IPv4, you study about IPv6, how to assign others in IPv6. It's the content of the network, okay? We use IP here, you discuss about it, but you don't go so deep, okay, in this course in particular. But another things, the communication protocol or the communication layer, the first thing need to define the address, but need to define how to send data in the network. One example, things that you enter in the dark room, okay? In the dark room, complete dark, okay? And you cannot see the other guy. And things that you need to talk with your friends, but you don't know where is your friend, and you need to talk. Oh, for example, Antonio, which time you go to the school? Okay.
What time? 6:10 a.m.
No. It's not a question. It's an example. Sorry. Okay. The example is, for example, Ernesto needs to send to ask you, Antonio. For example, each time you go to the school, for example, Ernesto, you are in the dark room. Okay. Nobody see nobody, and Ernesto say, "Oh, Antonio, which time you go to school?" And you need to give the answer, and you say, "Oh, I will go 8 p.m. or 9 a.m. I don't know." Okay. It's nice if you only both of you in the room, but think you are 30 people in the room, and the 30 people want to talk, want to order. It's crazy because you cannot see when you want. The only thing that you have is here because you don't have eyes. It's a dark room. For example, Ernesto will do the same question, but Adrian decides to do another question in the same time. What happens? Nobody understands nothing because 2 people talking at the same time. Did you understand the example? Yeah. So you need to define a way to send data in the channel, because most of the time in the wireless channel, the channel is a shared channel. For example, Ernesto wants to talk with Antonio, but Adrian wants to talk with Antonio at the same time. We need the communication layer need to define a way to organize the communication in the shared media. For example, one example is it happens in the Wi-Fi. In the beginning of the channel, you have a clock, okay, that you have a time clock that mark the beginning of a slot, communication slot, okay? And this type of the protocol, in the beginning, when Ernesto talks, he talks message and how many times he wants to talk, okay? And when Adrian say, oh, Ernesto talk during 1 second, okay, I can use the slot time after 1 second to talk. And you organize the talks like that, okay? It's another task that the protocols, the communication protocol need to handle. But this task is a very consume power task, okay? And the IoT need to have low power communication because a lot of time you need to install the sensor in a very hard place to go. For example, in the floors. For example, in the floors in some parts of the country, in the world, sorry, you have sensors that detect if the temperature in the floors to detect, for example, when you have a fire, okay? Fix the situation. In the forest, a lot of time you don't have electricity. You need to use batteries. And you need to install a sensor that don't consume a lot of batteries. That, for example, you install the sensor and the sensor works for 30 years or 20 years or 10 years, okay? It's the reason that this device, IoT device, need to have lower power communication. Cannot spend power, a lot of power to send data in the network. Routing protocols, again, in the same case of the forest, you don't have a base station like you have a router to everybody connect in this router. A lot of time, one device connects to another device that connects with another device that connects with another device and acquire the routers, okay? It's a very common routing, it's a very common topology that you can use in IoT. High speed and low latency communication. IoT use wireless channels, okay? But need to have high speed, okay? You need to send a lot of data in the wireless channel. But sometimes you lost connection. The IoT device needs to support to lost connection, okay? What it means? The IoT device needs to identify when you lost the connection, and identify what data he cannot send to the central location, and to when you have connection again, you send this data again. Not send all the data. You send only the data that you lost because you lost the connection. Any question, guys? Did you understand?
I have a question.
Okay, go ahead.
Could you explain in more detail how memory usage works in routing?
Yeah. It's amazing because you use this example in the retro. Again, I will share the whiteboard. Okay. Think this situation. You have 3 devices, okay? And in the red one is what's the name? Is the alcance, okay? Is, for example, is the red one means, for example, if you have, I call here A, B, and C, okay? The red one here is what the A listen. For example, when B transmits one data, for example, B transmits one data, okay? A can detect and C can detect, okay? However, what C talks, A didn't listen. Did you understand the speaker, Victoria?
Yeah.
Okay. In this case, you want that A, and B, and C listen everything. What you need to do? You need to have a routing protocol that enable that okay, B listen C. B, he transmits the C content to A, okay? Each what means the routing protocol, okay? It's a very simple example, but you use it, for example, in the car network. In the car network, you have a car here, another car here, another car here, and another car here, for example. And this car can talk with this one. This car can talk with this one. It's a full direction, okay? It is one to this one. And for example, this car detects that you have a crash or a problem in the road, okay? Like you use, for example, it's not exactly it, but think the example in the, what's the name? In the car application, I check here the name. The Waze, okay? For example, you detect that you have an accident. This car detects you have this accident, okay? It's not exactly the Waze works, okay? But just one example. You detect that you have a crash here, a problem here, okay? But you need to send this data for this car and to this car, because this car, if you have this problem here, this car is automatic the car and need to reduce the speed to avoid to go here fast, and you have a lot of cars stop because you have many cars and you cannot walk, okay? One example to here, this car send this data to this one because this one can listen this car, and this car routing this information to the car that this guy listen. For example, this one. Did you understand?
Yeah, but I have a question, like how can you fulfill the low memory requirement?
How can what? Sorry, I cannot listen here.
Can you listen to me?
No, I understand you, but I cannot hear the end of your question.
Yeah, about the low memory requirement, like how can we do that in the routing protocol?
Yes. Again, okay, I don't need this screen now. Okay, back to the presentation. Okay. It's not, again, it's not exactly the content of this course, okay, because you need to have the base of the routing, okay? And you study routing in the network course. But you have a different types of the routing protocols. I give you two examples. One example is you have, don't think about the IoT, think about the simple routing protocols. One example is you have a table, okay? In this table you see, you have one information. To go to, for example, Victoria address, you go for this path. To go to Antonia address, you need to go to this path, okay? You have a table inside each device that you have, okay? Or better, you have this table in a special device that the name is router, okay? And for example, when your machine needs to, for example, oh, I need to go to Antonio, you send this information to a query to this routing, to this router, and the router say, oh, to go to Antonio address, get this path, take this path. Okay, it's one example. In this case, your device don't need to have a lot of space inside your machine, okay? Because you have this special device which name is router, okay? It works, but not in the IoT scenario, because in IoT scenario, it works if the device is don't move. For example, if you have device in your home like air conditioner, the cafeteria, it works, okay? You install this, for example, give me a second, Jose, give me a second, I try to explain better. For example, in your home, the air conditioner, cafeteria, you can use in the access point to provide the service. You make query to the access point, oh, the path is this one. Or you only send the data to the access point, and the access point take care to deliver of the information to the destination. It works, okay? And the IoT device don't need to think about the routing. But it's not true, for example, if device that move like a car, okay, like a drone, or like anything that you need to move, okay? In this case, the device needs to have some intelligence. You need to have some address routing capability to understand where this address is, to see what is your neighborhood, and to exchange data with your neighborhood. And in this case, you have a different type of way to do this test. For example, you can detect all the nodes that is your neighborhood, okay? You have two problems. You need to detect the neighborhood. You need to store this information in the device. Or you only know one node and store the information about one node. The first node that you detect, you have less information to store. You have less speed to detect your neighborhood. The problem is, if this neighborhood, if node that you know stop to work or to live with your range, you need to detect again, okay? It's a problem. You have a different type of the protocols, routing protocols that you can use to be more efficient communication protocols. It's a very huge field to study, okay? Again, in this course, you have some ideas, but to completely understand, you need to understand the two things: wireless in Jeep and the routing in Jeep, okay? The both courses you don't have now. But when you study the communication, the media communication, I believe in 2 or 3 classes ahead, you study this type of things, okay? I don't know, I can answer your question, Victoria.
Yeah, thank you.
Jose, is the same or another question?
Hi, teacher. It's me. But
Yes.
I was wondering if there's like any material that I could research or something after the class. So if I have any question and I could learn a little bit further instead of just coming to this class.
Yes, I can share. But a question: it's about what? About the routing protocols or about the whole content?
The whole contents of the class, teacher.
The whole content. Okay, I will share some additional material to complement the content. I will do one thing. I'm looking for in the library some books that you can complement the content of the course. Okay, give me. I cannot do it today, but give me until Monday to check which books you have in the library, and I share this item in the Canvas in the Slack. Okay.
Yes, teacher. Thank you very much.
Okay, perfect. But again, if you didn't understand something, you can ask in the class, or can send the Slack later directly or in the group, and I can clarify. Okay. The problem is the first class and the second class is a very high level. Okay. I try to don't go so deep. Okay. Some topics you don't cover in this course, and I talk, oh, you didn't cover, but if you want to learning more, I can give you some additional materials, okay? So I will give a break, okay? I go, now is 15. We return, now is 11:50, am I correct? Okay, you return mid 12, okay, guys? And give a break, take a rest
Yes, teacher.
and 12, okay? See you.